All have a good day. I am K. Surya, working as assistant professor in the department of ECE at SNS College of Technology. In this video, let us see about Cmos. The term Cmos stands for Complementary Metal-Oxide-Semiconductor. This is one of the most popular technology in the computer chip design industry and is broadly used today to form integrated circuits in numerous and varied applications. Today's computer memories, CPUs, and cell phones make use of this technology due to several key advantages. This technology makes use of both p-channel and n-channel semiconductor devices. One of the most popular MOSFET technologies available today is the complementary MOS or CMOS technology. This is the dominant semiconductor technology for microprocessors, microcontroller chips, memories like RAM, ROM, EEPROM, and application-specific integrated circuits. CMOS complementary metal oxide semiconductor is a semiconductor technology used in the transistors that are manufactured into most of the today's computer microchips. In CMOS technology, both kinds of transistors are used in a complementary way to form a current gate that forms an effective means of electrical control. So the main advantages of the CMOS over NMOS and bipolar technology is the smaller power dissipation. Unlike NMOS or bipolar circuits, a complementary MOS circuit has almost no static power dissipation. Power is only dissipated in case the circuit actually switches. This allows integrating more CMOS gates on an IC than in NMOS or bipolar technology, resulting in much better performance. Complementary metal oxide semiconductor transistor consists of p-channel MOS and n-channel MOS as shown in the figure. So NMOS is built on a p-type substrate with n-type source and drain diffused on it. In NMOS, the majority of the carriers are electrons. When a high voltage is applied to the gate, the NMOS will conduct. Similarly, when a low voltage is applied to the gate, NMOS will not conduct. So NMOS is considered to be faster than PMOS, since the carriers in the NMOS, which are electrons, travel twice as fast as the holes. So the symbol for NMOS is shown here, which consists of gate, drain, and source. Next is PMOS. So the P-channel MOSFET consists of P-type source and drain diffused on an N-type substrate. The majority of the carriers are holes. When the high voltage is applied to the gate, the PMOS will not conduct. When low voltage is applied, PMOS will conduct. The PMOS devices are more immune to noise than NMOS devices. Next one is working principle of CMOS. So in the CMOS technology, both N-type and P-type transistors are used to design the logic functions. The same signal which turns on a transistor of one type is used to turn off a transistor of the other type. This characteristics allows the design of logic devices using only simple switches without the need for a pull-up resistor. In CMOS logic gates, a collection of N-type MOSFETs is arranged in a pull-down network between the output and the low voltage power supply rail. VSS are quite often ground. Instead of the load resistor of NMOS logic gates, CMOS logic gates have a collection of P-type MOSFETs in a pull-up network between the output and the higher voltage rail, often named as VDD. Thus, if both the p-type and n-type transistor have their gates connected to the same input, the p-type MOSFET will be on when the n-type MOSFET is off and vice versa. The networks are arranged such that one is on and the other is off for any input pattern as shown in the figure. CMOS offers relatively high speed, low power dissipation, high noise margins in both states and will operate over a wide range of source and input voltages, provided the source voltage is fixed. The next one is CMOS inverter. The inverter circuit is shown in the figure consists of PMOS and NMOS FET. The input A serves as the gate voltage for both the transistors. The NMOS transistor has input from VSS and PMOS transistor has input from VDD. The terminal Y is output when a high voltage is given at the input terminal of the inverter. The PMOS becomes an open circuit and NMOS switched off, so the output will be pulled down to VSS. When a low level voltage is applied to the inverter, the NMOS will be switched off and the PMOS will be switched on, so the output becomes VDD, or the circuit is pulled up to VDD. So which is shown here as a tabular column. So when input is 0 volts, the logic input is also 0. So output will be VDD and logic output will be 1. When the input is VDD, logical input will be 1, output will be 0. So the logical output will be 0. So this when input is 1, output will be 0. When input is 0, output will be 1. This is the case of an inverter. Next one is CMOS NAND gate. Here the figure shows a 2 input complementary MOS NAND gate. So it consists of two series NMOS transistors between Y and ground and two parallel PMOS transistors between Y and VDD. If either input A or B is logic 0, at least one of the NMOS transistors will be off, breaking the path from Y to ground. But at least one of the PMOS transistors will be on, creating a path from Y to VDD. So this is shown in the tabular column. So A and B are inputs, so which is 0, 0, 0, 1, 1, 0 and 1, 1. For a pull down network, when input is 0, 0, the pull down network will be off and the pull up network will be on, and so the output will be 1. So when the input is 0, 1, the pull down network will be off, pull up network will be on, and the output will be 1. When the input is 1, 0, also again the output will be 1, and the input is 1, 1, the pull down network will be on and the pull up network will be on, and therefore the output will be 0. Next one is CMOS NOR gate. A 2 input NOR gate is shown in the figure. The NMOS transistors are in parallel to pull the output low when either input is high. So the PMOS transistors are in series to pull the output high when both inputs are low, as given in the table. The output is never left floating. So here also 0, 0, 0, 1, 1, 0, 1, 1. So input will be 1 only when the output will be 1 only when the input is 0, 0. So there are several benefits of CMOS over TTL, or good noise margin as well as less power consumption. So this is due to no straight conducting lane from VDD to ground. Fall times based on the conditions of input, then the transmission of the digital signal will become easy and low cost through CMOS chips. CMOS is used to explain the amount of memory on the motherboard of the computer that will store in the settings of BIOS. These settings mainly include the date, time, and settings of hardware. TTL is a digital logic circuit where bipolar transistors work on DC pulses. Several transistor logic gates are normally made up of a single IC. Apart from this, it is used as a single power supply. They are very simple and the input impedance is high. Fan out is high, TTL is compatible, it's very compact, noise immunity is good, stability is very good, and it is robust mechanically, and designing is very well. Some of the disadvantages are the cost will be increased once the processing steps increases. However, it can be resolved. The packaging density of the CMOS is low as compared with NMOS. MOS chips should be secured from getting static charges by placing the leads shorted. Otherwise, the static charges obtained within the leads will damage the chip. This problem can be solved by including protective circuits, otherwise devices. Another drawback of the CMOS inverter is that it utilizes two transistors as opposed to one NMOS to build an inverter, which means that the CMOS uses more space over the chip as compared with the NMOS. These drawbacks are small due to the progress within the CMOS technology. Some of the applications are digital IC designs, computer memory, CPUs, microprocessors, flash memory chip designing, and it's also used to design application-specific integrated circuits. Let us take up some assessment questions. In CMOS logic circuit, the NMOS transistor acts as, the answer is a pull-down network. In CMOS logic circuit, the PMOS transistor acts as a pull-up network. In CMOS logic circuit, the switching operation occurs because the N MOSFET transistor turns on and the P MOSFET transistor turns off for input 1, and N MOSFET transistor turns off and P MOS transistor turns on for input 0. Thank you for watching this video.